So far, we have three methods that we can use to solve a system of equations. We can graph the two equations and find where they intersect. We can solve one equation for a variable and substitute an expression into the other equation. We call that the substitution method. Then we learned the addition method. And the addition method I think is the quickest way to get to the answer, but there's some systems, like this one up here, that I can't use the addition method right away. If I try to add these two equations together, I'm going to get 4a minus 1b equals 10, and I didn't get one of my variables to go away. So this is not helpful to me. But there is something that we can do to this system to make the addition method work. There is a property of equations that says I can multiply both sides of the equation by a number. And I'm going to take the first equation and multiply it by 2. And we'll see why in a second, why I chose to multiply by 2. The first equation then becomes 6a plus 2b equals 8. I'm going to leave the second equation exactly the same and write it underneath. Now look what happened. Now my addition method is going to work because I have a positive 2b and a negative 2b. When I add these together, I will have 0 b's. 7a equals 14, so a must equal 2. If a system of equations right away is not written in a form that you can use addition for, you can multiply the equations by any number you want so that this result will happen. You're looking for the coefficients of the variables to be the same number, one of them positive and one of them negative. Let's finish this problem real quick. If a is 2, then I'll use the first equation to plug back in and figure out what b is. Subtract 6 and b is negative 2. So the ordered pair 2, negative 2 is the solution. Let's try the multiplication method again. I am looking to have the same coefficients for one of my variables. One needs to be positive and one needs to be negative. So if I look at the d's, 7 and 5 don't have much in common in terms of factors and multiples, but 2 and 6 do. If I multiply this by 3, I'm going to get 6, and that's going to be really helpful when I try to add the equations together. And more so than just 3, I really want to multiply by negative 3, because negative 3 will make this negative. Since this is positive, they'll add together and be 0. So negative 3 is the number I want to multiply the first equation by. So I'm going to get negative 6c plus 21d equals 41 times negative 3 is negative 123. The second equation can stay exactly the same. 5d equals negative 7. Now I can add the two equations together. Negative 6c plus 6c is 0. So I'm left with 26d equals negative 130. Divide by 26, d is negative 5. Use one of my equations to plug d back into. So 2c minus 7 times negative 5 equals 41. 2c plus 35 equals 41. Subtract 35. C must be 3. So the ordered pair 3, negative 5 is the solution to This system looks slightly different than the ones we've been doing. So if we take a couple of steps to rewrite it into a form that we're used to, I think it'll be very helpful. We want to make sure that the variables that are alike are lined up, so the n's are vertical to each other. The c's are as well, but we usually don't have the numbers on this side. So I'm going to start by rearranging the equations, and I'm going to add 4 to both sides on the first one, and 7 to both sides on the second one. This form is more like the others. Now I need to come up with a coefficient for one of the variables that I can multiply the equation by to get. All right, 6 and 9, we need a common multiple here. There isn't a nice number that I can multiply 6 by to get 9. And there is a number out there and it's 1.5. I guess we could use that, but I would rather go and say, well, 6 and 9 have a common multiple of 18. So if I multiply 6 by 3, I'm going to get 18n. And if I multiply 9 by 2, I'm going to get 18n. And these we can eliminate. Just make sure that you make one of your variables negative. So I'm going to multiply this one by -3 and this one by +2. That way I'll get the correct coefficients for n that will be eliminated later. So this equation times -3 will have -24c equals -12. This equation by +2 equals 14. Now when I add the two equations together, the n variable goes away. I'm left with -4c equals +2. Divide by -4 and c is 1/2. Once I find that c is -1/2, I need to plug it back into one of the originals to figure out what n is. So let's use the first one. 6n plus 8 times -1/2 minus 4 equals 0. 6n, here's -4 minus 4. 6n minus 8 equals 0. Add 8 and divide by 6. 4/3 is what that reduces to. So now I have my value for c and my value for n. The ordered pair that is the solution to this system is -1/2, 4/3. Uh-oh, we have a system of equations that involves lots and lots of fractions. Let's take some time before we start solving this system and rewrite these equations into a much nicer form. If I look at the first equation, I have all of these fractions. If I multiply by the LCD of these fractions, they will go away. They will reduce down into nice whole numbers. So the LCD here is 12 between all of these denominators. So I'm going to multiply everything by 12. When I do that, I'm left with 2a plus 3b equals, let's see, 3/2 of 12 is 18. I'm going to do the same thing in this equation. The LCD between these two is 6. So if I multiply both sides by 6, I'm going to be left with 4a equals 3b. Now, these two equations are much nicer to look at, but they're still not in that standard form I use to add equations together. So my next step, I need to rearrange this one. Both variables have to be on the same side, and they have to line up the variables in this equation. So I'm going to subtract 3b from both sides. Excuse me, my marker not working. And get this equation. This equation and this one are the two that I'm going to solve using the addition method. So these are the two equations that I'm going to solve using the addition method. Let's rewrite them to clearly see what we need to do next. So I have 2a and 3b equals 18, and I have 4a minus 3b equals 0. Already I can see I'm ready for the addition method. My b's will add up to be 0 if I add the two equations together. 6a plus 0 equals 18, so a must be 3. Well, if a is 3, let's plug it back into an equation to figure out what b is. I can pick any of the equations that are up here. They're all true equations for a and b. This one seems to be the simplest one to me. So I'm going to say 4 times 3, since a is 3, equals 3 times b. So 12 equals 3b. b must be 4. The ordered pair 3, 4 is the solution to this system.